Hi folks, I just wanted to go over some notes for the next section of forces. Today we're moving from horizontal motion we did previously to vertical motions. There's a few important points you need to know when we're talking about this stuff. And they're outlined in your notes, so I just want to go through them quickly. If I have an object that's moving upward, so it's the same as we talked about before. If you're moving upward, then the acceleration is positive. If you're moving downward, the acceleration negative. If you have a rope like this in the example, it says the tension, which is how much force is in the cable or rope or string or chain or whatever you're doing to pull. The force of tension is the same everywhere between these 2 points. Between point A and B, it's all the same amount of force. Between B and C, it's the same amount of force. But between A and B and C, they're not the same. If you look at it, A has to support everything that's on the rope. From B down, it only has to support from C. And I'll have another a video with a slinky to demonstrate that in a little bit. If the mass is not moving or you're moving at a constant velocity, then the force of tension in the cable is equal to the weight. So this is the same principle we use for horizontal motion, where if you're moving to the right at a constant velocity, there's no difference between the applied force and the frictional force, so there's no net force to cause acceleration. And if objects accelerate upward or downward, we can solve them using the net force. So our free body diagram looks familiar, except there's no forces to the right or the left because the object is moving straight up or down. So Ft is really any force that's in a cable. We usually use it when we're talking about the forces in ropes, but it can be used any cable. But for what we're doing, we're just going to use it the upward force in one of these vertical motion questions. So the force of tension is in a rope, and it's always pulling upward, and force of gravity is always downward, and we have no other ones. So if we do the F net equation for this, F net is simply all the forces up, which is the force of tension, minus all the forces down, which is gravity. That's all it is to this one. We'll make substitutions like we did in the other equation. So F net is ma. You remember that. Ft, we don't change. It's just a measured force. We have to use a device. And force of gravity is mg. So this formula right here, remember, do your F net equation, do your substitutions, and it's all plug and chug. And there's the F net equals ma that goes along with it. So I'm going to do an example out to go along with this, but I'll do that in the next video. Thanks.